AI and neural networks are extremely powerful and can learn anything these days. But what exactly is the reason behind this? The answer, it turns out, is what's known as an activation function, and more specifically, a rectified linear unit activation function. So let me explain. Here we have a simple neural network, and this is taken from one of the best courses out there to understand neural networks, which I will put in the comments below. But basically you have X, which are the inputs, and then these are the neurons, which basically are a linear combination of a weight with the input, and then you add a B, that's known as bias. But essentially this is a linear combination of all these parameters. What makes it non-linear is this activation function that you can see is able to classify the blue dots from the red ones. Now here's another one. When you don't have that activation function, you can see that the network is not able to classify the blues from the oranges. So basically the activation function is nothing but a max of 0 and that value, and in this case you can see that whenever the input value X is negative, it's 0, the output is 0, and then when it's positive, it's basically a sum multiplied factor of that variable. And ReLU is just one kind of activation function. We also have tan H, and linear is when you don't have an activation function. But amongst all of those, it turns out ReLU is extremely powerful and super simple to implement. And here's an example of code, and I highly recommend this course, which walks you through the basics. And here's a PyTorch model where you have the hidden layer, and then you simply add this torch.nn.relu, which is nothing but a max of 0 and X. So there you have it. If anyone asks you what exactly is the secret behind neural networks and AI, you can tell them it's the ReLU. And if you're either a professional getting into the field, or you've been training a lot of models, pre-trained models specifically, it's really important to also understand the basics. So good luck.